students, I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, today lecture I will be discussing principle of proportioning for concrete. Okay. So, in this particular lecture, what do we mean by proportioning of concrete mix? So, design of concrete mix is an art which involves determination of the proportions of cement, water, coarse and fine aggregates and admixtures if any, which produce concrete possessing specified properties both in the green as well as in hardened states with the maximum overall economy. So, in this one what is important? Workability, strength and durability. So, these three things is very important in design of concrete mix. So, for a standard medium grade concrete, following two basic assumptions can be made while we are designing the concrete mix. So, first is the compressive strength of concrete is governed by water cement ratio, and second, for a given aggregate characteristics, the workability of concrete is governed by its water content. So, how much water is there that will decide workability of the concrete. Okay. But suppose you want to design for high strength concrete. So, in this case mixes are specially selected cementitious materials like we are using fly ash, granulated grounded blast furnace slag, metacholine, silica fume and admixture. Chemical admixture like superplasticizers are important for achieving a low water cement ratio. So, low water cement or cementitious material ratio is important parameter. So, as the water cement ratio increasing, their strength of the concrete decreases. So, mix proportion. Suppose you see the mix proportion here. So, for determining the mix proportions of cement, aggregate, admixture and water, two methods are adopted. First is by adopting nominal concrete mix. Such concrete is called nominal mix concrete. So, this nominal mix concrete can be made with nominal mix, and that can be used only for ordinary quality of concrete, ordinary group of concrete. So, what is ordinary group of concrete? So, that ranges like M10, M15, M20. So, these are the ordinary, and that can be used only for a small work, not for big work, and this type of concrete cannot be used for important work, and that has to be decided by site engineer. Okay. And cost of this nominal mix is always higher than design mix. So, we must go for design mix. Another category will be here design mix. So, by designing the concrete mix, such concrete is called design mix. So, we have two types of mix, one is nominal mix concrete, another is design mix concrete. So, we have two type of important methods of mix proportioning. So, let us discuss. So, when we want a economical concrete and with all the desirable properties like strength, compressive strength, workability for compaction, transportation, placement, finishing purpose at green stage, and hardened condition we are bothered about the strength of concrete. So, we need a good quality, good strength of concrete. Okay. And third one, durability. So, durability is also addressed in design mix concrete. So, our concrete must be durable, their longevity will be more. So, they must serve their service life satisfactorily. Okay. But if you consider the nominal concrete mix, so that we can't give the guarantee of durability, and so always we should think regarding design of design mix concrete. So, what is the principle of mix proportioning? So, we have certain principle by which we can achieve the design concrete. So, one is design concrete or nominal mix concrete. So, first one, type of mix, whether it is a design mix concrete or nominal mix concrete. So, if it is a nominal mix concrete, means we have not to go a rigorous design, but by just taking the some nominal percentage of cement, coarse aggregate, fine aggregate, water, we can achieve certain grade, but that grade is permissible only up to M20 grade of concrete, not higher than that. So, earlier code 1978 to IS 456 1978, they were permitting up to M25 grade, and that there they were using the volume batching, but in IS 456 2000 they have banned batching by volume. You have to batch this by weight, and you can use only up to M20 grade of concrete. Okay. So, that is the difference, and their ratios they were used to take by volume. Then we have grade designation. We have to grade the designation should be known what grade of concrete you need. So, that may be range from M10 to M100. So, you may design, and even you can go for more than M100 grade concrete, but you have to refer some special literature for that. Then type of cement. So, type of cement is also very important, and apart from type of cement, different grading is also important, minimum amount of cement is important, and maximum amount of cement is limited. Similarly, maximum nominal size of aggregate must be known. So, what should be our maximum size, whether it is a 20 mm downside or 10 mm downside or 40 mm downside or 80 mm downside. So, those data must be with us while we are designing the mix. So, then we have minimum cement content for design mix concrete. If nominal mix concrete, amount of cement is fixed, that is why it is a costly. But if you are going for the design mix, in that case some amount of cement must be restricted, and maximum condition is also restricted. Then there is a restriction of maximum water cement ratio in a design mix or even in nominal mix. So, we can't go beyond that amount. So, if water cement ratio is more, what will happen? There will be a durability problem. So, once it depends on the environmental conditions, exposure conditions, we have to restrict water cement ratio. So, it should not be more than that. Then we have workability. So, workability is also a very important parameter when we design a mix, whether this for different purpose IS 456 has given the slump value. So, this much slump is required for that particular category of concrete. So, that has been discussed in earlier lecture. So, workability can be decided by slump or by compaction factor or VB test. And mix proportion we are having for nominal mix concrete, there is a certain limitation. What should be the ratios, and that is also by weight, not by the volume, according to IS 456/2000. Then we have exposure condition. So, as per table number 4 and 5, so in table number 4 and 5 they have restricted the exposure conditions as per IS 456. So, what should be the maximum or minimum condition? So, what should be the maximum water cement ratio and minimum amount of cement, and another is maximum temperature of concrete at the time of placement. So, that is also important. So, we can't be going on placing the concrete if the temperature is more than 40 degrees centigrade. So, we have to consider the weathering condition. So, weather condition is also important. So, we have to decide whether it is a hot weather or it is a cold weather. So, depends on that we have to plan the strategy. Then method of placing, that is also important, whether how we are going to place the concrete. Okay. Then degree of supervision, degree of supervision is also important. If degree of supervision is not good, then if the degree of supervision is not good, what will happen? Quality of concrete may deteriorate. So, a standard deviation will be more. So, if more standard deviation will be there, then you have, for achieving, say I want to achieve M40 grade concrete. So, you have to increase the mean target strength to achieve those particular grade of concrete with compliance criteria. So, these are the principles of mix proportioning. So, here we will discuss about the nominal mix design, and another lecture we will discuss the principle related to design mix concrete. So, grade of concrete. So, they have grouped the grade of concrete in 3 category. One is ordinary concrete. So, ordinary concrete ranges between M10 to M20. So, M stands for mix, and the digit, say I am using M20. So, this digit is a characteristic strength. What is this? This is the characteristic strength of concrete at the age of 28 days, which is performed on 150 by 150 by 150 size cube by standard method. Okay. So, these are the things we have to understood here. So, M10 to M20 grade concrete comes under ordinary concrete, and then we have a standard concrete. So, a standard concrete in IS 456/2000, earlier it is up to M55, but now it has been amended in 2013. So, according to that amendment, this group go up to M60. So, this one comes under a standard concrete, a standard concrete. And high strength concrete ranges from M80 to M85, M90, M95 and M100. So, this is the grouping. So, this has been grouped into 3 category. This has been grouped into 3 category. So, first category is ordinary concrete. So, ordinary concrete is M10 to M20, a standard concrete is M25 to M60, and high strength concrete is M65 to M100. So, these 3 category important. So, suppose you want to discuss nominal mix concrete. So, nominal mixed concrete can only be done, nominal mixed concrete only can be done up to this M20 grade concrete, M20 this category of concrete. Okay. So, IS 456, if you see the IS 456, so they have given the provision of nominal mix concrete. So, here this has to be done by weight, this has to be done by weight, not by volume. Weight batching is there, not by volume batching. Okay. So, what is the system here they have given? So, they have taken 50 kg of cement. So, total quantity of dry aggregate by mass per 50 kg of cement to be taken as the sum of the individual masses of fine and coarse aggregate. So, here for 50 kg of cement means 1 bag cement, 50 kg 1 bag cement is how much? 50 kg. So, for this one we have to use this much of coarse aggregate plus fine aggregate. So, this is the amount of fine aggregate plus coarse aggregate, this is the restriction. So, if it is a M5 grade concrete, this value is 800 kg, M7.5 625 kg, M10 480 kg, M15 330 kg, M20 250 kg. So, these are the, suppose you have the proportionate ratio like this. Similarly, what should be the ratio of fine aggregate to coarse aggregate? So, fine aggregate to coarse aggregate, they have given the ratio nominally 1:2. If your aggregate size is, maximum aggregate size is M20 and down, maximum MSA, you can say maximum aggregate size MAS is 20 mm and 20 mm and down. So, then you can use the ratio of 1:2. But suppose your maximum size of aggregate is say 12 mm and down, 10 mm and down. So, in that case we have to increase the fines. So, in that case ratio you can go 1:1 and 1.5, you can go a ratio of 1.5. You can give a ratio of 1.5. Okay. So, this is for 20 mm and downside, this is 1.5 ratio, this is for 10 mm and downside aggregate. And if your size of aggregate is larger, say you have a 40 mm size. So, in that case that ratio you can get 1:2.5. So, but just in trial it is not that 1:2, just to take some amount and see the workability, whether you are going to get the workability properly or not. So, based on that you do some trial. So, this 1:2 ratio may be 1.75, it may be 2.25 or 2.2 like that. Okay. So, that thing we have to understand properly. This is for 40 mm maximum size. Okay. So, this is a maximum size of aggregate, Okay. So, this is important, and similarly they have restricted the water cement ratio. So, water cement ratio, if you see water, if you see here water, they have given for M5 grade 60 kg of water or 60, even you can take this in liter also, because if you have a good things liter you can take, that is not the problem. So, similarly for M7.5 45 kg, M10 grade 34 kg, M15 grade 32 kg and M20 30 kg or 30 liter of water you can take. So, if you see the water cement ratio, let us see the water cement ratio of M20 grade concrete. So, what is the restriction they have done? 50 water is your 30 kg, water is 30 kg and cement is 50 kg. So, if you calculate you can get 0.60. So, this is the restriction. Likewise, you can get the restriction water cement ratio for any grade of concrete. Okay. So, but this design is meant here, but if you consider the IS 1978 code, there they are using the volume mix, still that is in the practice in the field, but they should not do because volume of cement varies. If it is a packed one, their volume is around 29 liter, but suppose you have opened in the bag, that will expand around 32 liter to 42 liter. So, that much is the big variation. So, average people need to take 35 liter, 35.2 liter. Okay. So, that is not the correct way, because strength is governed by the amount of cement. Workability is also water cement ratio is governed by this condition. So, what was the earlier code, that should not be adopted. So, M10 suppose you want to use. So, they were taking 1:3:6 by volume, here 1:2:4 by volume, and here M20 means 1:1.5:3, and they were having M25 also. M25 means they have 1:1:2 was the ratio. So, all these thing was by volume batching. So, they are not talking about the water. So, this was the method they used to adopt earlier. So, this should be rejected, that should not be permitted in the field, because volume you do not have proper system to measure the correct volume changes. Okay. That is important. So, we will take one example for how to achieve this grade. So, let us say I will talk for M20 grade concrete. Let us say I am talking about to make the nominal mix for M20 grade concrete. Okay. So, what is the weight of cement? Weight of cement you have to use 50 kilogram, you can mass or force, okay, 50 kilogram, and weight of water you have to use 30 kg, or that is equivalent to 1 liter. So, here water cement ratio is how much? 30 by 50 is nothing but 0.60. So, now we have to calculate amount of coarse aggregate. So, coarse aggregate, fine aggregate plus coarse aggregate is 250 kilogram. Fine aggregate and coarse aggregate is 250 kilogram. So, what should be the ratio of, suppose this we want to take, say I want to take 1:2 ratio. So, what is the amount of fine aggregate? So, fine aggregate will be nothing but 250 divided by 1 plus 2. So, this thing we are supposed to calculate here. Okay. This thing we have to calculate 250 by 3. Okay. 250 by 3. So, this one I think it will come 83.33 kg. So, what will be the coarse aggregate? Amount of coarse aggregate will be equal to 2 times of 83.33. So, this will become 166.67 kg. This is for 1 kg. So, what is the amount of water? 30 kg. So, like this we have to take this amount. So, let us say I want to find out the ratio. Let us say I want to find out the ratio. So, what is the ratio? Ratio for, suppose you want to find out the ratio. So, say this is the cement and coarse aggregate, fine aggregate plus coarse aggregate into water. So, what is the value we have got? Cement is 50 kg, fine aggregate is 83.33 kg and coarse aggregate is 1.67 kg and water is 60 kg. Water is 60 kg. Okay. So, just you divide by the 50, just you divide all these things by 50, you can get the this ratio. You can get this ratio. Okay. Sorry, this is a 30. Sorry, this is a 30 kg. So, this will become 0.60 and this one you divide by 83.33. I think that you can calculate. You fill here, you can get the value here. So, like that, suppose you want to calculate certain volume, just to certain weight of concrete, you can find out for the amount of concrete, okay, amount of ingredients with the help of this ratio. Okay. And suppose you are not able to get the proper workability, suppose due to some reason we are not, we want some more workable concrete. So, for making the more workable concrete, what is the tendency? Mason you to put more water. So, if he is putting the more water, so you have, you know the relation for water cement ratio. So, say this is our strength and say this is your water cement ratio. So, relation is like just like this. Okay. This is for if it is not compacted, then it will go like this. Okay. So, let us say our strength of the concrete is here, water cement ratio is here. So, for this particular water cement ratio, say for 0.6, we are able to get M20 grade concrete. Okay. So, if you are going to get M20 grade concrete here, so if we are adding more water for workability purpose, we are adding some more water for workability purpose, what will happen? This will go down, water will increase and this will not be a M20 grade concrete. So, what we have to do, suppose I want to put 1 liter more water in the concrete for better workability requirement. So, proportionately what we have to do? What we have to do proportionately, you increase the amount of cement keeping coarse aggregate and fine aggregate constant. So, say 1 liter you are putting the water, additional water for getting better workability. So, what you have to do? So, how much amount of cement we have to increase? So, amount of cement we have to increase. So, 1 liter of water divided by 0.6 water cement ratio. So, that will become 1.33 kg of cement, 1.33 kg of cement, sorry, yeah, or no, 100. I think it will be 0.16, yeah, that you can calculate 100 divided by 6. So, it is 1 this is a 40 0. So, like that we have to calculate this value. So, that much cement we have to increase, that much amount of cement you are supposed to increase. 1.67 kg of cement you increase and increase 1 kg of water, then only will be in a position of getting the M20 grade concrete. Thank you.